today we are going to talk about geostationary and non-geostationary satellites. So, first we look at geostationary satellites are satellites that orbiting the Earth in geostationary orbit at the same speed as the Earth rotating at the same latitude, specifically the equatorial latitude. Okay, this is the equatorial latitude. Latitude means like going horizontally. That is the latitude. That is at the 0 degree is equatorial. Geostationary satellites are satellites that orbiting the Earth at the same speed as the Earth rotating at the same latitude, specifically the equatorial latitude. Equatorial is the 0 degree of the horizontal line. Geostationary orbits around about 35,786 kilometers above the Earth. The satellite here. Geostationary satellites are a distance. There is a distance here. A distance about 35,000 kilometers from the above the Earth. A satellite orbiting in geostationary orbits in the same spot in the sky and directly above the same area at all the time. It rotates according to just the same speed at the Earth rotating at its latitude, because Earth rotates from the west to the east at its own axis. Alright, at its own axis it rotates. Next, what is the use of geostationary satellite? It is used for communication, as we know, for internet, broadcasting cable TV, global position system, GPS, radio signals, weather forecasts. Okay, we can place our satellites in 3 orbits. There are 3 orbits we can place the satellites. So the first one is the geostationary orbit, which is 35,786 kilometers above the Earth. Second one is Middle Earth orbit, MEO, about 8,000 kilometers above the Earth. And the last one is the Low Earth orbit, from 160 kilometers to 2,000 kilometers above the Earth. So a non-geostationary satellites are satellites that are same place in geostationary orbit. Okay, let's look at this diagram. The Earth is here. If we place our satellite at a low altitude, which is about 160 to 2,000 kilometers above the Earth, the satellite require a high speed to travel. It only needs 90 minutes to make a complete circle. So, but for our satellite, if we put at the high altitude, about 35,786 kilometers, and then it requires 24 hours to rotate around the Earth. Then we can capture all the things that happen in a day, because the orbital period requires 24 hours at this altitude. That's why our satellite or geostationary satellite are placed at the altitude of 35,786 kilometers above the Earth. Okay, since we know that further away from the Earth, gravitation force is weak. So to stay in circular orbit, a satellite must orbit at a low speed, which is it requires orbital period of 24 hours. That is just same like the Earth, rotate at its own axis for one day. a very high altitude like the moon, which is 370,000 kilometers away from the Earth, it requires 1 month to make a complete circle. It is the furthest away from the Earth. Okay, as we know that a satellite relies on the Earth's gravitational force to provide the required centripetal force, this one. Centripetal acceleration that the satellite needs is A equal to V squared over R. Gravitational force that provided by the Earth is Gmm over R squared here. Okay, that's all for now.